Okay, so we're going to get into the meat of programming with Java with these three types of topics: methods, classes, and objects. Now, I'm going to encourage you, be sure to practice at home what you learn. Even if you don't have a homework assignment that's associated with it, try to sit down and practice these things, because the more you do it, um, it's going to stick in your memory, and you're going to just feel more natural at programming and what you're having to do. Let's talk about some of the things we'll be looking at. So particularly, we're going to describe what method calls are and where you place them. We will identify the parts of a method. Um, you'll learn about how to create a method and a method that returns values. And then you're going to transition into taking a little bit closer look at classes and objects. And although I've said it before, and I don't want you to, to get overwhelmed with this statement, instantiation. Anytime you take an object, take a class and you create an object, you are instantiating. Taking the class and instantiating an object. So you're going to look at that ability, okay, of instantiating objects. And you can't really talk about creating a class instance unless you're also looking at methods themselves, methods in a class. It's the meat of what we're doing. And then creating classes, as I've said, from instantiating objects from the class you created, and then using those methods in the class off the instantiated object. And with that, this is where the topic of the creation of constructors comes from. A constructor is how you tell an object to tell a class to create that object, and it plays a key role. And we're going to be looking at some different kinds of constructors as well as we get to the end of this week. The video that I put out about IntelliJ and how to use it, I did a sample of two types of constructors. And so hopefully by the end of this week, you'll have a good appreciation of using these, as well as classes, and using a class as a data type, as well as other ways of doing it. And this is going to be important as we go forward. Okay, so what is a method? What do you guys think a method is? I know all of you are looking at your PowerPoint slides and going, well, it says here So the simplest way to describe a method, it's just a simple program. It's a program module. It's a piece of code. And it's designed in such a way that it contains code that's going to perform a certain task. Methods, they can be invoked or called. And as you see in your PowerPoint slide, invoke or call, that terminology is going to be used over and over and over again throughout your software development career. How a method is invoked or how it's called. So you kind of need to get familiar with those phrases. The calling method is often called the client method. And the called method that is invoked is called from a calling method. Right? It's pretty straightforward. Okay, so let's look at for a moment this piece of code. This is a class called first class. And you can see that it has a standard public static void main method. All Java classes that are automatically invocable, meaning that when you call Java this class, it must have a main method. Okay, and so that main method always must be public static void main with string. That's an array. That's what that those two square brackets means. It's an array of strings, space, whatever the title of that parameter is called. Sometimes the parameter is called args. Some methods could be arguments, whatever. But in general, that method signature must be the same in order for it to be called. This particular method calls two statements. One of them is display address, and the other is the static classes system.out.println. And you can see that system.out.println, it accepts a string literal. Okay, you guys have done this particular main method quite a bit. Let's take a deeper look here. The public static void main method is the method that automatically is called when you call the class. So Java first, it's going to automatically call that public static void main method, right? Everyone's familiar with that, right? If no public void main method exists and you say Java first, it's going to display an exception. And some of you have seen that exception before. No main method found. Because you can't invoke a class like that without it having a public static main method. Now, not all classes have to have the public static void main method. You can have a class that's what we call a plain old Java object. It's just a data type for storing data. And we'll talk about more of those later on this week. The other methods that are called from the main method, you're going to find that later on, as we go through this class, those methods can also be called via keyboard events, mouse clicks. They can be called, of course, from the main method. They can be called, say, you have a web service set up and it calls it from the parameter, the URL string. It can call a method in your class. So all of those are ways that you can call those methods. Let's talk about it a little bit more though. Much of this is very basic stuff. And hopefully by week 3 you understand how the general layout of these classes are. The location though of this one particular method that we see on the class, the display address, this is crucial actually, because for it to be called, it has to be placed in the main method. If it's not in the main method, then it can't be called, especially in these simple command line programs. So if you wanted, you could write other methods in the first class, and you could place them in the main method and call them, but they would either have to be static, they'd have to be a static method, or you would have to instantiate the first class inside of the main method. So when I say instantiate the first class, you would say first, because that's the name of the method, the name of the class, right? And then I'd give it a variable name. Maybe I'm just going to call it first. So first, lowercase first, equals new first, parentheses. Now I've instantiated, and semicolon at the end. Got to have the semicolon. Always remember that. Now I've instantiated an object, and I could call that object from within my main method. All right, let's take a little bit deeper look here at methods in general though, because we're going to get into instantiating objects. And I keep repeating this because it's one of those things that you're going to hear over and over and over again, and it's important that you hear it early and often. Yeah. Let's break down let's break down a method in general though for a moment. So a method, it must contain a method header. And the method header is often called the method signature. It's sometimes called a method declaration. Whether it's called a method signature or a declaration, it has to have that piece of code at the top. Underneath the method header is the method body, and the method body is the piece of code that's in between the curly brackets or the curly braces. So you have an opening curly brace at the end of your method header and a closing curly brace. Okay? And the stuff in between those curly braces, this is the logic, this is the tasks, the stuff that does the work. This could be logic, it could be a print line statement, it could be some type of mathematic calculation, it could be text parsing, you could even have database calls that are done within the method body. It could be input-output processing. It could be a great number of things, but it has to be located in the method body. Now, sometimes we call the method body the implementation. And the reason we do that is because we also have certain class types called interfaces. And interfaces do not contain implementation. They only contain the method header. So you can just kind of tuck that away in your memory somewhere. We'll get to that later. All right, so methods, they can also call other methods. And you saw that with the public static void main method, right? So look at our code again. And I mentioned this a minute ago that our display address is inside I'm getting tongue-tied. Our display address is inside a static void main method. Now, because it's inside a static void main method, that display address must also be static. Why? Because we can tell that from our code sample that it's not instantiating the first class. That name is horrible. I don't know why they called it first, because now it makes it kind of a double meaning and can be confusing. You can see though there that here is the first class that I'm pointing at. If this display address was not static, in order for it to exist inside of a static, in order for the call of that method to exist inside of the public static void main method, you would have to instantiate the first class. Okay? So it's static, and so you don't have to do that. Okay? You always want to remember that difference between a static method and a non-static method. Static methods, you don't have to instantiate the class it resides in. You can literally say first dot display address, or the name of the class dot the name of the static method. So as you look at that, this is important to think about static and non-static. Okay, let me give you a little extra here. This is not in your textbooks because maybe it's a little too far ahead, but I want to throw this out because I've seen a lot of Java developers write code and they don't think about making their code manageable. A method is designed to contain a distinct set of logic. It should do one thing. Now, this is my opinion, okay? But a method should do one thing. And the reason is because if your method does more than one thing, anytime later in the future you need to use that class to do something else, now you have to think about the side effect of that class doing something else, that method doing something else as well. A method should only do one thing. Always make that your rule of thumb. Never allow your method to do more than one thing. I mean, it has one goal, right? One goal it should do. So the reason we create methods is if you have a piece of logic inside your public main void, let's say public static void main method, right? You have a whole bunch of logic in there that's doing something. Maybe you should take that logic that makes sense as a group and move it to a method because it makes it more manageable. And then you give that method a name that describes the pieces of logic that it does. The other reason you'd use a method is now you have a piece of code that's reusable. So think about display address. Display address is reusable in the sense that the logic it contains can be called over and over and over again from multiple locations. I don't have to type out all of the print line statements in display address in order to use it. I can just call display address. All right. As I said before, methods should do one thing. So have you guys ever heard of the KISS principle? Keep it simple, silly. I didn't say stupid because I don't like that. Keep it simple, silly. Your method should be simple in construct. Okay, they should just do one thing. Okay, all right, that's my soapbox. I'll get off my preaching platform there and move on. All right, so method heads or method signatures, they often contain other attributes. All right, so sometimes we call these attributes the access specifiers. Access specifiers are public, private, protected, and there's also a package level. So package level is where you don't provide any access modifier. So public, private, protected, or none, which means package level. Um, Other attributes that a method header has is the return type. So return type, this could be a data type or it could be void. If it doesn't return anything, it should be void. The method name itself, which is the identifier, it should be self-documenting, right? What I mean by that is the name itself should indicate what it does. How weird would it be if system out print line did number calculation instead of printing a line? So make your method names self-documenting. Make them represent the logic that they're doing. Okay. Method headers or method signatures, they always contain a parentheses. The parentheses is important for designating the types of parameters that they might accept or the data that might be passed in. All right, and now here's the last part. There are some rare exceptions where a method might call another method, but that only happens in anonymous classes. And we're not going to get into anonymous classes probably ever in this course. Okay? In general, you do not create a method inside of a method. You can't do that. All right? Okay. Except with anonymous classes. And I've looked through the book and I don't think you're ever going to get into anonymous classes in this course. Okay, so let's talk about your access modifiers. Remember, access means whether you can gain entry or how you're going to allow entry into something. We have 4 different access modifiers. We have public, private, protected, and we have package level, right? So public means the world can see this method. If your if your member variable is public, the world can see that variable. That's what public means. It's public. If it's private, no one can see that method except the methods or variables inside the class. Outside the class, it's restricted. They can't see it. And I'll show some examples maybe here in the next 20 minutes of how some of these different methods would work, but from outside using different objects. But just keep that in mind. Package level means that the method, package level again is where you do not declare an access modifier. You don't declare public, private, or protected. So it'd be void, my method, parenthesis, curly brackets, right, the body. That means that it can only be seen from classes that are subclasses. You may not understand that yet, but you just kind of remember that a class can have a subclass. So package level can only be seen from subclasses. And then the last one is protected. Protected is very similar to package level. It can be seen from subclasses, and it can be seen from classes within the same package. Okay? So protected, seen from subclasses and from things in the same package. If it's package level, it can only be seen from a subclass, but not from other classes in the same package. All right. Let's look at this example again. Okay, here's our sample code. You have the public static void main method, the main method in the application, and the public static void main method, it has to be public. Otherwise, your application won't run, right? And then you have the display address. And here, display address, it's not required to have public, but it's a good idea. And by having it public, any class outside of the class called first can see it. If it was private static, they couldn't see it. All right. And the static modifier in this case means that both of these methods, they don't require an object to be created. All right, let me pause there. Let's kind of rehash some of the things we talked about. What are some questions that are coming up in your mind here? Something that maybe you're not quite getting or understanding. Are you afraid to ask a question, or has everyone really got it so far? If you really got it, good. But if you have a question, don't be afraid to ask. Yes. No, you're not. Oh, you're just moving your arm. Okay. All right. Well, I'm going to go on. All right. So now we get into the return types. The return type, as your slide says, it describes the type of data that the methods send back to the calling method. So the address, display address says public static void, which is the return type. And void means what? Nothing's returned. Exactly. And of course, then we have the identifier, which is the display address. All right. So if no data is returned, the method return value is void. If display address said public static string display address, then it returns what type of data type? It returns a string. If it said public static int display address, it would return what type of data type? It would return an int. So whatever's there in that that return type value, that's the type it will return, and it must return that type. It must return the type. In fact, you'll get a compile time error if you have public static string display address, but you do not return a string. It won't compile. It'll tell you, I'm sorry, have a nice day. You got to fix this problem. I'm just not going to work for you. Okay. All right. Let's look at other examples of the return type here. Both of these, main method and display address, they both do not send any information back through the method. Now, don't get this confused, because when we use the system out print line, that's using a input output. That's not using a return value. Return value in this case only refers to this area that I keep hovering with my mouse. Okay, this is the return value. You can still print things out all day long and it still be void. Okay, but the return type is the area you want to pay attention to. All right. So method names, they can be any legal identifier. They must be one word. And what I mean by one word is it isn't a word with spaces in between. It can be a word that has, camel case or underscore, right? But it cannot have a space. It cannot be a Java keyword. All right, so what are some of the Java keywords? Throw some of them out to me real quick. Public, private, package. Those are some keywords, right? What are some others? New, string. What is that? No, that you can do that. Yeah. Go to, for, while, break, else, if. There's a bunch of keywords, right? They can't be any of the keywords. Now, if you're using IntelliJ, IntelliJ will be nice and say, sorry, that's a keyword. You can't use that. Uh-huh. Mm-hmm. Yeah. Yep. Yep. Absolutely. Okay. So it cannot be a Java keyword. You guys want to learn that because when you have an exam, those keywords will be on the exam. Did I hear groaning? Don't groan. All right. So let's look at method name, second part of this. All right. So we have here main, which you can have other applications, by the way, that have a main method. Okay. They can be called main. That's not a keyword. But the combination of all of this is kind of important. Because as soon as the Java compiler sees this, it knows that it makes the class as a whole invocable. Right? All right. But this is the identifier, the name of the method. And this is a single word. This down here is also a single word, but you're saying, but Mr. Rogers, it's two. No, there's no spaces. It's camel case, and that's fine. And it's okay to make your method names very straightforward. If you need to say, this is my method name, all in camel case, that's perfectly legal, right? Okay. The parentheses. So every method header contains a set of parentheses that follow the identifier, and they may or may not contain data in them. And the way that you specify them is the data type space the variable name or the parameter name. Inside of a method signature, inside of the parentheses, it's always what we call the parameter. Okay. And it needs to be a fully qualified identifier. So if you have not included an import statement for that identifier, you can actually use the full package name in that identifier. So for example, there is a date object under java.util.date, and there's also a date object under java.sql.date. And so when you use both of those objects in a class, you have to specify which date object or which date class you're referring to. So that's where it means fully qualified. com.oracle. Whatever the name is, or java.util.date. That's a fully qualified identifier. All right. Any questions there? All right. So here is the public static void main method. The main method has one parameter, and that parameter is a string that is an array. And that array's parameter name is called args, which is an abbreviation for arguments, right? The other one, public static void display address, you can see it doesn't have a parameter, and that's fine as well. If you want to add more than one parameter, you're going to put a comma in between those parameters. So for example, if my first parameter in my method is a string, it'd be string, the variable name, comma, the next data type, that variable name. So you could have string, my name, comma, string, last name, right? So commas are used there for separating the parameters. All right, so arguments are the data items you use to call the method. Parameters are the data items received by the method. So when you're calling a method, those are the arguments. When you're creating the method, meaning I'm actually trying to figure out how I'm going to group my code together and I decide I'm going to create a method, that's called the parameters. Those are kind of important to keep in mind, the separation between those two. Most software developers will understand what you're talking about if you get them confused, but that's what they are. All right. And then we have implementation hiding. Implementation hiding is encapsulation of method details within a class. Encapsulation. Early on, I showed you a picture of a capsule. And inside that capsule, it had all of these things encapsulated in it. Encapsulation means here is the code and you just accept it. You don't really care what it does. It's encapsulated. You just use it. Okay? So the calling method needs to understand only the interface to the called method. All right, now we get into the interface. Interface is a special keyword, by the way. Interface is another type of class. So you could have public class first, or you could have public interface first. The only part of a method that the client sees or reacts with is in a method. And a method that's inside of an interface doesn't have an implementation. All right. Do you guys understand what that means? Should I whiteboard it? Public class first, curly brackets, right? And I have a method called public static void display. And I'm cutting it off the name for short because I don't want to keep writing. All right, and in here I've got some logic that does something. This piece right here inside the curly brackets, this is the implementation. Okay. If I have an interface, public interface first, curly brackets, curly brackets. They always require that for all classes or interfaces. And then I say public static void display parenthesis semicolon. You guys see the difference? The class has a method body, the implementation. The interface does not. That's what I'm talking about. Now, as we get into inheritance, creating interfaces gives you a lot of power to do some cool things with coding. You can pass around to an object the interface, and as long as the interface has a class somewhere that's implemented off of it, it will call the implementation. So an interface could have multiple implementations of that interface. How many of you like pizza? Pizza. You guys like pizza, right? Yes. Oh, yeah. I was going to do a health check. But yeah, as you know, that not all pizzas are created equal. Some are from Joe 10, some are from Pizza Hut, some are from Domino's, and some are from Caesars, and some are from my favorite pizza in the world is Papa John's. Pizza. All right. But the pizzas themselves, they all have certain components. Crust, those specified components could be an interface. And the implementation of the pizza could be a bacon ranch chicken barbecue pizza, or a chocolate marshmallow s'more pizza. You guys are not going to pay attention to the rest of the class, are you? You're going to be thinking about pizza. But that's the implementations of the type, the interface. Okay? All right. So the implementation hiding is when we use those interfaces. All right, let's go on. So these are some optional access modifiers: the return type for the method name, the parameter type, the local name for the parameter. These are the things that you define for a method. All right. So here we have a method. This is called calculate gross. And where are we? We're at slide 20. All right. So we got a few more to go for. I'm going to do some examples in class. Okay. So this is the public static void calculate gross. All right. It's static, so what does that mean? Someone tell me. The method calculate gross is static. What does that mean? Its parent class does not have to be instantiated. Right? We don't know what its parent class is because we just have a code fragment here. Because it's static, the parent class does not have to be instantiated. So it could be, if the parent class name was first, you would just say capital FIRST dot calculate gross, because it's static. If it was not static, then you would have to instantiate the class. Okay. So here we see the identifier calculate gross, then we have the parameter type, which is double. And double is what type? Remember what type of double is? It's not an int, right? An int is a whole number. A double is a decimal. Very good. And so we have the parameter that it's identifying that we're calling is the hours. All right. Then we have final double std underscore rate. Your eyes itchy? I'm sorry. It's after lunch and everyone is ready to go take a nap. Oh boy. I'll move over here. All right, so final double standard rate. And this is a constant because you can see they've also taken the extra to make it all caps underscored, right? 13.75. And then we have double gross. This is another private member variable. It's inside the method. And so we have a calculation. It says gross equals the hours times the standard rate. And then we're doing a system out print line, hours plus the string literal hours at $ plus the standard rate equals per hour is the gross. Okay. So you guys are getting tired of me. So let's switch gears. On your box. Okay. Everyone, it is installed on the desktop here in the lab, so go ahead and open up IntelliJ. And I'm going to do this slowly, but I see some of you are on your phones, so I really need you to follow along with me, okay? All right. So we're going to open up IntelliJ. And once you get to the opening screen, we're going to create a new project. Okay. You guys can see what I've got on the screen, right? I'm going to create a new project. And then you're going to come up here to this new project. Mine may be a little bit different because I've got the Ultimate Edition, but at the top you still should have Java. Does everyone see that? Okay. Click on Java, select your SDK. I'm using 11, but just you should have 13 installed. And click Next. You should have a, you're still opening? Okay. Does anyone else have that? Where's this is import settings screen? No? Okay. All right. Let me know, is everyone here by show of hands if you're on the same screen I'm on? Okay. Are you almost there? Okay, so click Java in the top left corner. So you say next, start. Okay. You're going to create a project from templates. So click the checkbox. Okay, are you there? Okay. What's that? Yeah, create project from template. Okay. Move my cable out of the way. All right. Now we're going to click next, and we're going to create a pizza. Since you guys like pizzas. All right. In your base package, you could say com.your last name. It's an easy way to do it, or you could just leave it in the default. Okay. Click Finish. And then you're going to be at this screen. And mine has a tip of the day. You can read the tip, but just close it and go on. What it has done for me is it's automatically created a main class with a main method. Does everyone see that? All right. If you bring your mouse over here to the left where it says project and you click on that, it'll expand it out. And we're going to click into the pizza, go down to the source, click on the package. And if you haven't had a chance yet to watch the video that I posted, it will describe what the package is for you. Okay? Because this is really a folder structure that's hidden from view called the first folder, parent folder is com, the second folder is MDR Solutions. So you're going to right click on the MDR Solutions folder or your package folder. Going to click new and then a Java class. And we're going to call this class pizza. And just hit enter. Okay. Is everyone at the screen I'm at? Okay. So let's create some methods to describe our pizza. Pizzas usually have a crust, right? So let's type a private, and let's call it int crust thickness. Does that work for you all? So that's how thick the crust is going to be. And let's say private int, private string. Let's create a sauce. All right. And then what's another type of, private, let's say string topping. Because this is just going to be a simple pizza. We're only going to have a one topping. Right? All right. And then we're going to say private Boolean has cheese. And we're going to initialize this one to false. Okay, so real quick check here. So far, all of my member variables are private. So what does that mean? What does that mean? They can't be seen outside of the pizza class, right? That makes it kind of hard to use as a pizza class though, right? If we can't see what's on the pizza, right? So what would we do to initialize the pizza? How about we create a constructor, which we're going to get into later this week, but this is as good a time as any. So we're going to say public pizza, open parenthesis, and then we're going to say curly brackets like that. Okay, if you watched the video yet, or if you've already watched the video, this by itself is called a default constructor. And if you do not create a constructor on your class, this one here exists implicitly. Okay, so we're going to override the default constructor and we're going to give it some items. So I'm going to give it an int of crust thickness with a comma, because remember, it's just like a method signature, right? It's comma separated. And then I'm going to give it a string of sauce, a string of topping, again, comma, and then Boolean has cheese. All right. So this is the constructor declaration. And in the constructor declaration, I have these parameters of the types of things that will accept on a pizza. So we're going to assign it now. So we're going to use the this. This is a keyword, by the way. Another keyword. And the this keyword always refers to the class that it's in. So you could say this is this class. It's the class that I'm in. This, the keyword itself, is implicit. So I don't have to have it. I could just say crust thickness equals, because when I do it like this, I'm implicitly referring to it. But for readability, we want to use this because we want this to refer to up here and not that. I need to come up with some different language semantics here for you guys. This and that. All right, so I'm assigning the parameter crust thickness to the member variable crust thickness. Do you guys see that? All right, I'm going to do it again. So now we're going to say this sauce is going to be assigned from that sauce. And this topping is going to be assigned from that topping. And this has cheese is going to be assigned from that has cheese. Okay. So this in a nutshell is the constructor that creates the pizza class. And because I haven't created the plain old constructor, you can only create this pizza class through this constructor. The plain old constructor is a single set of parentheses on the pizza class, But because we've overridden it, it doesn't exist anymore. If I wanted to create that one again, I would have to say public pizza, like that. Then when I go to create the pizza class later, I could create it. Now, the pizza class could also be created like this. We could create a pizza class with a different set of constructors. We could say a pizza just has a string of topping. And then we would assign a topping to it. And we would say, whoops, right? And then we could assign the has cheese to be true because it's in the constructor. We could say that this sauce is chocolate. Chocolate. That's a good sauce, right? Some of you are like, I don't know what kind of cheese it is, but all right. This is just an example. All right, so let's create a method now. Let's create a public void display pizza. And so I'm just going to use my standard system out print line. And I'm going to say that the pizza is the topping is this topping. The let's see, the sauce is this sauce. We're going to say cheese is going to be true or false, right? This has cheese. And the crust thickness okay. So I have a very simple pizza class. It has a display pizza. It returns what type? Void, right? All right, we're going to create one more method in here. And we're going to say, we're going to create some getters. So public string get topping. And I'm not passing in a variable, but I am going to say return this topping. Public string get sauce. And I'm going to return this sauce. Public string this, int this get crust thickness. IntelliJ is trying to be smart for me and suggest what I'm asking for. Public Boolean is, or let's see, has cheese. Return this has cheese, right? Now, can some of you tell me what I did? You notice that the member variables are private, right? But now I've created methods that are public that return the member variables, right? Okay. Are you guys good with this, the pizza class? Any questions so far about what I've typed? Do we have any static member variables in this thing? Do you see any? No, so that means that everything that's in here, if we want to access it, we have to access it by instantiating the pizza class, right? All right. So let's go into the pizza class. Let's go into our main method now. All right. You're in the main method, and let's instantiate our pizza. So we have pizza, and I'm going to call this one pepperoni pizza, pepperoni pie equals new pizza. All right. So at this point, I have a constructor that I'm calling here. Do you see that? And what constructor am I calling? If you control click onto the pizza, it'll take you right to it. Did you see that? In IntelliJ, you can control click right on it, and it'll take you into that constructor. Well, let's take out, or let's comment out. Comment out the pizza constructor for a moment. Save it. Go back to your main method, and IntelliJ is going to tell you something. What is it telling you? It says I cannot resolve the pizza constructor because it just doesn't exist. However, when I control click on it now, it tells me the only two constructors that it recognizes. All right, so I'm going to go with the first one. It brings me back over to this pizza class. So let's go back over here. I'm going to give it a, let's see, my constructor says the first one is thickness. So I like thick crust. I'm going to go with a 3. All right. And then my pizza class is the next one's sauce. So I'm going to do tomato sauce, I guess. Or how about, let's see, how about garlic pesto? All right, so the next one is toppings. Well, I called it a pepperoni, so I might as well say pepperoni. Pepperoni. And then I have one more, and that is, does it have cheese? And I'm going to say yes, because I like cheese. All right. For readability's sake, I'm just going to do this for you guys. Okay. IntelliJ has put up these little labels here to tell you what they are. All right, so now I've instantiated a pizza. All right, this is the class, this is the variable name, and now I'm instantiating it with new constructor. Okay, so let's see our pepperoni pie and let's display the pizza. All right, so I'm just going to come over here and cheat and click on the run method, and it's going to build my pizza. Let's actually build the Java class. And there you go. The topping is pepperoni, sauce is garlic pesto sauce, cheese is yes, and the thickness is 3. All right. Well, let's create another pizza as well. Let's create a pizza, and we're going to call this a s'more pizza. Equals new pizza. All right. So again, for readability, I'm just doing this. So the crust, I don't like my s'more pizzas to be so thick, so I'm just going to do a 1 thickness on it. And my sauce, I kind of like chocolate. No, what do I like on my sauce for a s'more pizza? I like marshmallows. Marshmallows. Marshmallow cream. There we go. And then let's see, my topping. Oh, well, my topping has to be. You want graham crackers? Well, how about chocolate? Choc. Oh, there we go. Hershey Kisses. Okay. Go big or go home, right? Yeah. All right. And let's add a second one. Let's add Hershey Kisses and more marshmallows. Marshmallows. I don't think I'm spelling that right, but it doesn't matter. All right, what else? We want some graham crackers. Oh, we want crushed. Crushed graham crackers. All right, comma at the end. And then has cheese. Do we want cheese on this? No. I just don't know. I don't. That would be kind of freaky if we had. Well, we could add cream cheese, but we're gonna have to change our pizza implementation to accept that type of pizza. All right, but we can do that. We can change our pizza implementation. All right, so I'm going to s'more pizza, display pizza. Now if it would only display an image, right? All right. I have a good friend of mine who works for Papa John's in Louisville, Kentucky. Because Papa John's is from Louisville, Kentucky, just like KFC and. Interesting story, by the way. I sat on Colonel Sanders' lap when I was an infant. He attended my uncle's church. Colonel Sanders founded KFC when he was like 82 years old. He started cooking chicken when he was 82 years old. That's crazy, isn't it? Anyways, back to the other guy, the Papa John's guy. All right, so let me see here. There's our pizza. We got topping is Hershey Kisses, sauce is marshmallow cream, cheese is false, and thickness is 1. All right, and there's our other pizza too. He works for Papa John's and he does the online ordering. And this type of class that I just created is very similar to the type of class that they use when they're creating pizzas online. It's taking all of the variables and it's creating an order list, and then they're going through and using it. So this is very much a real world scenario for a pizza. All right. Now, one of you said, let's modify our pizza. So maybe we should take this out and say string, instead of has cheese, just say cheese, right? Which means that we now have to change our constructor because it doesn't make sense to have a Boolean right here, right? So we'll change that. And then this is just cheese, and that's just cheese. And this is, well, let's just make this one mozzarella. Mozzarella. I do not know how to spell mozzarella. Hey, this is not grammar class, okay? This is computer programming. All right, so now we're going to go down. We're fixing our bugs in our program, by the way. So I don't have a has cheese anymore. I just have a cheese because this is kind of cheesy. I'm adding a blank print line statement at the end. And I'm going to do something else too. I'm going to do this. It's just a spacer line. So when it prints, it doesn't look so cheesy. All right, so now we haven't even used our getter method yet, have we? All right, so this is returning a string, but up here it's Boolean. So how do we fix it? You change that one, right? Okay, so we save it. We'll go back to our main class. We'll come over here. Now it doesn't work anymore. All right, so for our pepperoni, what type of cheese are we going to give it? Okay. Cheddar. Pro. Iade. All right, we're moving on, guys. All right, so down here for the s'more pizza, we wanted to put what? Cream cheese? You thought I'd misspell cream, didn't you? Okay, so we save it. We're going to click run main method, and I'm going to move this up a little bit so you can see. And there's our pizza. All right. Who's buying? Okay, so let's go back here. Really what you've done, okay, this is the basics of object-oriented programming. Now, we could take this a step further. And I don't even know if this is in your lesson this week, but let's take it a step further. Let's create a just use Java class and then change it to interface, and we'll just call it pi for right now. Okay, so we have a pi, and we want to make some things that are generic, right? So if I go back to my pizza class, display pizza is pretty generic. So let's just do public void display. And actually, you don't even have to have the public on this one, because when you implement the pi, it automatically will do that. Okay, so let's go back to our pizza, and we're going to come up here to the top, and we're going to say implements pi. All right, now mine throws a squiggly error, and yours should as well. If you hover over the squiggly error, it says class pizza must either be declared abstract or implement the abstract method display in Pi. So what does that mean? It means I need to come down here and I need to say public void display and save it. And you can see here, IntelliJ says, gets a little eye icon. It says it's implementing the method in Pi. All right. So I'm going to put inside my display method, display pizza. All right. Pretty straightforward, right? So let's go back to our main method. And instead of calling this pizza, let's just call this pie. My pie is now a pepperoni pie, which equals a new pizza. The interface is pie. The implemented class is pizza. Pizza implements pie. All right, so I can do this. But down here, this doesn't work anymore. Why? Because display pie only has display. Pi only has one method called display. So I'm just going to take that out and do that. Now, what do you think is going to happen? Because the actual object I'm instantiating now is the interface pi, which could be a pizza. All right. Let's make it a little bit more interesting. We have time, right? We have 10 minutes. You guys good for 10 minutes? We have less than 10 minutes, don't we? All right, so I'm going to create a new class, and I'm going to call this my pot pie. All right? And guess what pot pie is going to implement? Pie. And so I have to declare the variable, right? I have to public void display. Now, I'm going to cheat because we're running out of time, okay? So I'm just going to copy some of these variables here. And I'm going to change some of this. Obviously, I can't have a pizza. I've got to have a pot pie for my constructor. Same thing here. Pot pie. And crust, sauce, topping, cheese. Sure, that'll work. Let's change this to vegetable, though. And let's change the topping to meat. Okay. So we got meat, and this one's, what was the other one? Sauce, meat, and vegetables. Sauce, oops. Sauce, meat, mint, vegetable. Come down here. Meat is meat, and vegetable is vegetable. For simplicity's sake, I'm going to remove that one. And this is the meat. This is the vegetable. Everything else looks pretty good. We're going to put our display pizza, but that just doesn't make sense. So let's call this display pot pie. Change that there. Pot pie. Okay. So we have two types of pies, right? We have a pizza pie and we have a pot pie. All right. We're going to go back to our main method. And we're going to change our pepperoni because that one's kind of boring. We'll keep it pie, but over here we're going to change it to a pot pie. And let's see. Sauce meat. Oh, the meat. Let's make this chicken. And the vegetable, carrots, and how about that? Cancun. Hey, it's a saipan pot pie, okay? All right. Oh, one other thing. Let's go back to our pot pie method here. And we're going to add one other print line. We're going to say system out print line. I am a pot pie. And in our pizza, system out print line, I am a pizza pie. All right. So we got our main method. We got a pepperoni. Doesn't make sense. Chicken, Cancun, pot pie. All right. You guys are getting hungry, right? Not from the pot pie? All right, here we go. So what I'm trying to show you is an example of polymorphism as well. Because both of them are pies, but they're different kind of pies, and they both implement the pie. All right, so we will run it, and then you'll see that you now have I am a pizza pie and I am a pot pie. Make sense? So two different ways to implement and create and work through things. All right, guys. Yes. You want me to give you my code? You're making me nervous, man. This is copyright infringement already. Oh, you just want the Cancun pot pie, don't you? Okay. All right. Sure.